Assuming that you haven't run your audio wiring alongside of AC power wiring, AC hum or buzz on an audio system is usually caused by ground loops. Ground loops can also create problems on video systems, such as noise bars scrolling up or down the screen. A ground loop occurs when two different AC-powered devices have their inputs and outputs connected together. The problem is more likely to be worse when the devices are plugged into different AC outlets. For example, AC-powered floor monitors at the front of the room connected to a mixer at the back of the room, or the mixer connected to equalizers or amplifiers in a separate room. Since the addition of computers and video projectors, these ground loops often occur when a computer input or output is connected to the audio mixer, or even more so when a video projector is added to the system. Before we talk about solutions, we need to get a better understanding of the basics. First of all, what are ground loops? Let me try to explain as simply as possible. Let's look at two AC outlets in different locations in your building. Outlet A is wired to your breaker panel through one cable, and outlet B is also wired to the same breaker panel through a different cable. Because there is resistance involved in the wiring, and possibly the connection points, the voltages at each of the outlets will be slightly different. Although you may think that the ground connection is 0 volts, it isn't really. If you were to measure between the ground pins on each outlet, you would find a voltage difference. Depending on the quality of your building wiring and grounding, you could find up to a volt or two difference, maybe more. If the outlets are wired to separate breaker panels, the difference will be even greater. When considering low-level audio and video signals, even a fraction of a volt difference is significant. If you have a simple sound system with only a powered mixer and a wired microphone, you have only one ground point. This is the AC plug for the mixer. The only other potential ground point is from the housing of the microphone to the grounding of the building. In most cases, the microphone is well isolated due to the microphone clip and the rubber feet on the stand. Even if someone is holding the microphone, there is enough isolation unless they are standing in bare feet on a concrete floor. So, in a configuration like this, you are not likely to have ground loop problems. If, however, you add another AC-powered device to the sound system, such as a powered floor monitor or guitar amplifier, you now may have to deal with a ground loop. Let's look at the guitar amplifier situation. Because the amplifier is plugged into a separate AC outlet, its AC ground is now connected to the mixer ground through the audio line interconnecting the two. The voltage difference between the two grounds creates a current flow through the wire, which causes a 60 Hz hum or buzz to be injected into the input of the mixer. To eliminate this problem, you need to break this interconnection of the grounds. One way which often works is to remove the AC ground connection on one of the devices. This way there is only one ground point. Although this is a simple solution, it is frowned upon by the electrical industry. The ground pin connects the chassis of the device to earth ground as a safety feature. If anything happened to cause the AC hotline to touch the chassis, the ground connection would provide protection by quickly tripping the AC breaker. Without this feature, if a problem did occur, anyone who came in contact with the chassis, even through the guitar cable, could receive a nasty shock. Needless to say, this is not a desirable thing. The proper solution is therefore to break the ground connection between the two devices, in this case the guitar amplifier and the mixer. Hang on to that thought, because at this point we're going to take an important sidetrack. We're going to talk about balanced and unbalanced audio systems. Every professional sound system needs to use balanced inputs and outputs. Here is why. An unbalanced system uses a two-conductor cable. There is a center conductor which carries the signal and an outer shield which is grounded. This shield provides the return path or zero reference for the signal and also provides some protection against low frequency and radio interference. The noise protection provided by an unbalanced system is quite minimal. It is only marginally safe to run a distance up to 15 or 20 feet, especially with low-level signals such as a microphone or electric guitar. A balanced system, on the other hand, has two wires for the signal. The signal is sent 180 degrees out of phase between the two wires. It still uses a grounded shield to protect against low frequency and radio interference, but the shield wire in this case has nothing to do with the signal. Here's a drawing of how signal and noise is handled in each of these cases. An unbalanced system is very simple. It consists of a signal source with a single output referenced to ground. The signal comes from the output of the source through the center conductor of the wire to the input of the receiving amplifier. The foil or braid shield around the wire provides the return path for the signal and also protects the center conductor to some extent from electrical and radio interference. Although the source signal might start out clean, it picks up interference or noise along the wire. This is because the wire is acting as an antenna. By the time the signal reaches the amplifier, the noise has been added to it. The resulting output from the amplifier consists of the signal plus the noise. This noise might be so small that it can hardly be heard above the signal. It could also be so large that you can't hear the signal because the noise drowns it out. Often it's somewhere in between. A balanced system is a little more complicated. Instead of a single conductor plus a shield between the signal source and the amplifier, there are two conductors plus a shield. One conductor carries the main signal, while the other conductor carries the inverse of the same signal, 180 degrees out of phase. The two together are referred to as a differential signal. As this differential signal is passed through the wires, they pick up the same noise as the unbalanced signal does. By the time it reaches the amplifier, both the positive and negative signals have the same noise added to them. Keep in mind, however, that although the two signals are 180 degrees out of phase with each other, the noise is in phase. These wires are connected to a differential amplifier, which subtracts the out-of-phase signal from the in-phase signal. These signals are referred to as -A and A, respectively. When they are processed by the amplifier, the output is equal to A minus A, which equals 2A. Because the noise on the two lines is in phase, it is subtracted from itself and thus cancels itself out. The equation for this is the amplifier output equals A plus noise minus A plus noise, which equals A plus noise plus A minus noise, which equals 2A. This means that the signal has doubled and the noise has cancelled out to zero. For this reason, all sound systems need to be balanced. Now back to our main discussion. Using the guitar amplifier as our example, when connecting it to the mixer, we need to do two things to the signal. We are coming from the preamp output of the amplifier to a microphone input on the mixer. Because the amplifier output signal is line level in the neighborhood of up to a volt or more, and the microphone input on the mixer is expecting only a few fractions of a volt, we need to significantly reduce the amplifier signal before it gets to the mixer. Also, the amplifier output is unbalanced, so we need to convert it to balanced because the microphone input is balanced. The easiest way to accomplish both these tasks is to use a direct interface or DI box between the two. The input to the DI box is made for unbalanced line level, but the output is balanced microphone level. You need to keep the unbalanced input cable short, no more than about 15 feet, but the balanced output cable can be as long as you need. This doesn't eliminate the ground loop, however. In order to do this, we need to break the ground connection between the amplifier and the mixer. Remember that with an unbalanced system, the grounded shield conductor is needed as part of the signal, but in the balanced system, it is not. Therefore, we can eliminate the ground loop by simply disconnecting the ground from the DI box end of the balanced cable. Most DI boxes have a switch to do this. As long as the shield is still connected at the mixer end, we maintain our noise protection for the cable. There is no safety hazard because we are not affecting the AC grounding. There's one more thing that the DI box does for us. It not only breaks the ground interconnection, but it also isolates the input of one device from the output of the other. A passive DI box does this with a transformer, while an active DI box does it slightly less effectively using electronics. Rather than extend this discussion longer than necessary, suffice it to say that this transformer is an electromagnetic device which passes audio signal between its input and output without any physical connection between the two. As a result, even if there were some ground loop effects on the signal wires, they would be eliminated by this isolation. Okay, so much for DI boxes. But what about when you don't need to convert from line level to mic level? You can't use a DI box for these cases. For this example, let's consider the powered floor monitor. A powered monitor is just a speaker with a built-in amplifier. We could just as easily use a computer mixer, mixer amplifier, or any other line-level combination as our example. Again, the mixer and powered speaker are plugged into different AC outlets and interconnected using a balanced audio cable. The mixer output and speaker amplifier input are both line level and balanced, so we don't need to do any conversion. We just need to decouple the grounds. This is done with an AGDC2 line level decoupler. Like the DI box, it breaks the ground connection between the inputs and outputs and fully isolates the inputs from the outputs. The AGDC2 is a two-channel device which can be used for stereo or two separate mono sources. All the inputs and outputs will operate as balanced as well as unbalanced. This allows you to convert unbalanced inputs to balanced outputs, and vice versa. Electrosystems makes cables to connect any line-level audio source to any line-level audio destination through this unit. Although we have been talking about audio devices plugged into separate AC outlets, you can also experience the same ground loop problems with devices plugged into the same AC outlet. Even though the ground voltages may be the same at the plug end of the AC cord, that doesn't necessarily mean that there is no AC voltage difference on the signal wires. If you are interconnecting equipment with all balanced inputs and outputs, you are less likely to experience AC hum or buzz than if one or both devices are unbalanced. This depends, however, on how your equipment handles the signal wire grounding. This problem often occurs when connecting computer or DVD audio to a mixer. Adding a video projector makes it even worse, because now your computer or DVD player, mixer, and projector grounds are all interconnected. Again, the AGDC2 in all the audio lines will usually solve this problem. In this example, unbalanced computer audio output is connected to the line inputs on the mixer. You are likely to experience a ground loop between the computer and the mixer, especially because the computer output is unbalanced. Adding the AGDC2 between the two will break the ground loop and at the same time fully electrically isolate the two units. The same is true for a DVD, mixer, projector combination. Another common use for the AGDC2 is to connect the sound from your main sound system to a remote amplifier in another room, may be used for overflow. Often the mixer output is balanced, but the input on the remote amplifier is unbalanced. Run balanced cable from the main mixer output to an AGDC2 located beside the remote amplifier. Then unbalanced from the AGDC2 to the remote amplifier input. This way you can usually interconnect the two with no trouble at all. In summary, always use balanced inputs and outputs wherever possible. And if you do experience AC hum or buzz, it is most likely caused by a ground loop, which can usually be eliminated with our AGDC2 decoupler or a DI box. The AGDC2 is used for interconnecting line-level audio, balanced and unbalanced, and the DI box connects line level outputs to balanced mic level inputs. You will find both of these in our web store. Thank you for watching this video.